Hi guys, welcome back again. In today's session, I will walk you through solving question 3 of this year. So let's start. The following table shows part of the instruction set for a processor. The processor has two registers, the accumulator and an index register. So these are the instructions, the assembly language instructions and the explanation. Then question A. The current contents of memory are shown. This is the address, this is the data. The current contents of the accumulator and index registers are shown. The accumulator index register. Complete the table by writing the contents of the accumulator after each program has run. Okay, so how this is understood? So we are asked to write just the accumulator contents. So in writing the accumulator contents, after these instructions has been executed, so let's go back to the table that is provided for us so that we can understand how to write or how to execute each of these instructions. So the first one is LDM50. Okay, so when you are to do this, go to the table provided for you. LDM means immediate addressing. Load the number into the accumulator. So this number after LDM is loaded into the accumulator. And if you go back to the question, the number is 50. So that means in the accumulator, 50 is loaded. Now the next thing is INC ACC. INC ACC, if you go back to the table, it means add 1 to the content of the register. So whether accumulator or index register. So since the instruction is INCACC, that means add 1 to the what? To the content of the accumulator. That means the content of the accumulator becomes what? 51. Is that understood? So LDM50 adds 50 to the accumulator. INCACC means increase the number in the accumulator by what? By 1. Then the next thing is SUB1. So you go back to the table again to check what SUB is. Okay. So 1 means you can see an hash before 1, which means number 1. So SUB means subtract the content of the given address from the subtract the number n from the accumulator. So you are asked to subtract the number from the accumulator. What is the number? 1. So that means you subtract 1 for 50. The content of the accumulator is 50. When you subtract 1, it remains 50. So that means the accumulator content is now 50. I hope this is understood. If I start again, LDM50 means add this number 50. Like I told you, that hash means anything that follows an hash means that number is a ternary number. Okay. So LDM50 means add 50 to the load 50, not add. Load 50 to the accumulator. Okay. Load 50 to the accumulator. After loading 50 to the accumulator, INCACC means increment the content of the accumulator by 1. So that becomes 51. SUB1 means subtract 1 from the content of the accumulator, then 50 is derived. I hope this is understood. Now the next one, so LDI51. So LDI51 means is an indirect addressing. So that means the address to be used is at the given address. So load the content of this second address to the accumulator. That means you are loading the content of the address to the accumulator. What does that mean? So LDI51 means you go to address 51. When you get to address 51, the value is 50. So that means you go to address 50. The value is 48. That means 48 is loaded to the accumulator. I hope this is understood. So LDI, it means the address before it, you go to this address. When you get to this address, okay, when you get to the address, then the content of the address is what you have in the accumulator. So LDI51 means go to address 51. When you get to address 51, you met 50. Okay, so the content of address 50, so this 50 is now the new address. So you now go to the new address to get the content of 50. So I hope this is understood. So that means 48 is loaded into the register. Now add 52. For add 52. Is there an hash before 52? No. That means 52 is not a number. 52 is an address. If there is an hash before 52, then 52 is a number. Since there is no hash before 52, that means 52 is an address. Okay. So add 52 means you add the content of the address to the accumulator. So add 52 means add the content of address 52 into the accumulator. And the content of address 52 is what? Is 49. Is this understood? Then you add 49 to the content. And the content of the accumulator is what? Was 48. So when you add this, then you get 4 plus 4, that is 97. So the content of accumulator is now 97. So I hope this is well understood. Now, the third one. So the content of the address is now 97. I hope this is well understood. Now the third one, LDR2. Now for LDR, it means load the number to the index register. LDR, load the number to the index register. So if you look at it, there is an hash before, so that means 2 is directly loaded to the index register. So IX contains what? Contains 2. The number is loaded into the index register. Okay. Now, the next thing, LDX50. LDX is an index addressing. It means from the address from address plus content of the index register. That means that the new address is the address plus content of index register. So what does that mean? LDX 15 means the new address for the LDX is this address 50 plus the content of the index register, which is 2. That means the new address is now 52. Okay, so that means that you now load the content of the calculated address to the accumulator. So the content of 52 is 49. Okay, that means 49 is now loaded into the what? Into the accumulator. I hope this is understood. So 49 is now loaded into the accumulator. So DEC accumulator means reduce 1, that is deduct 1, subtract 1 from the content of the accumulator. That is DEC accumulator. That means the content of the accumulator is now what? Is now 48. I hope this is understood. Now, the last number, LDD 52. LDD means load the content of the address to the accumulator. So what is the content of 52? The content of 52 is 49. So that means 49 is loaded into the accumulator. Okay. SUB 54. SUB 54 means subtract. So since 54 does not have an hash, that means it is an address. So you subtract the content of the address from the accumulator. So subtract the content of 54 from the accumulator. So what is the content of 54? The content of 54 is 6, isn't it? So that means you subtract 6 from the accumulator, which means what? Which means this will be what? This will be 43. INC accumulator means increase the content of the accumulator by what? By 1. That means the content is now 44. I hope this is well understood. So now to the next question. The processor includes these bit manipulation instructions. The instruction and explanation. So these are the bit manipulation instructions. The current content of memory are, these are the address and these are the data in the memory. The current content of the accumulator is shown. So this is the content of the accumulator. Now complete the table by writing the content of the accumulator after each instruction has run. The binary number 1111 is reloaded into the accumulator before each instruction is run. So that means before any of this instruction is run, this 11111 number is reloaded into the what? Into the accumulator. So that means the first instruction is LSL number 2. Okay, 2 is not an address, it's a number because there's an hash. So if you don't know what LSL is, go to the table that is provided for you. LSL means bits in the accumulator are shifted logically n places to the left. Zeros are introduced onto the right hand end. So LSL2 means shift the bits in the accumulator 2 places to the left, and the content of the accumulator is what? Is 1, 2, 3, 4, 5, 6, 7, 8. So if you shift these 2 places to the left, that means this will be out, this will be out, isn't it? So that means this comes to the left, 1, that will remain 1, 1, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So zeros will what? Will be replaced by the what? At the right, according to this instruction. Bits in the accumulator are shifted logically any places to the left. Zeros are introduced onto the right hand end. So that means I have 0, 0. So the new content in the accumulator is 6 ones and 2 zeros. So I have this as 1, 2, 3, 4, 5, 6, 1, 2. I hope this is understood. Now the next thing, XOR 100. So you go to the table, XOR 100. So this 100 is not a number, it is an address because it does not have hash. I hope this is understood. Now XOR address, bitwise exclusive operation of the content of the accumulator with the content of the address. So that means we do the exclusive OR operation of the content of the address and what? And the content of the accumulator. Is this understood? Now, what is the content of the accumulator? That is 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Don't forget, the question says that this 8 one is reloaded into the accumulator before each instruction. So you don't say that the content of the accumulator was initially 111 and 00. No, it has been reloaded according to this instruction. And the content of address 100 is what? Content of address 100 is 0401101. So that will be 1, 2, 3, 4, sorry, 4 zeros, 1, 2, 3, 4, 1, 1, 0, 1. So what are we doing? Exclusive OR, okay, of the address and the accumulator. And exclusive OR means 2 bits will be 0 if they are equal, but will be 1 if they are different. So this means 1, 1, 0, 1, 0, 1, 1, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1, 1, 0, 1, 1, 0, 1. Then the result is what? 1, 2, 3, 4, 0, 0, 1, 0. I hope this is understood. Now the last question, and 103. So you go to the question, to the table, and 103 is an address and not a number, okay, because it does not have an hash before it, then is an address. So and 103 means bitwise AND operation of the content of accumulator with the contents of the address. That means the content of the accumulator and address. So it is AND with the accumulator. Remember, the content of accumulator is still 8 ones, right? Because it is reloaded, isn't it? So that is 1, 2, 3, 4, 5, 6, 7, 8. What is the address? Address is 103. So what is the content of address 103? That is 00110111. So that is 0011. Let me check again. 00110111. 0111. And the operation is what? And operation. So the 1 and 1 is 1. 1 and 1, 1. 1, 0, 1, 1, 0, 0. Then the result is what? 0, 0, 1, 1, 0, 1, 1, 1. So I hope this is well understood. That is the end of this question. So I hope this is well understood. So thank you for your time. If you have any question, please drop them in the comment section. Thank you for your time, and see you in the next section. Thank you.